Dash. Hey everyone! Welcome back to Biochemistry Simplified. Thanks for tuning in to part 2. If you enjoyed the first video, you're in the right place. Don't forget to like, subscribe, and hit that bell icon so you don't miss out, because I'll be dropping more videos.
Continuation of the glycolytic pathway, we're gonna be looking at the payoff phase, which is the rest of the article from step 6 reactive steps to step 10. So recall that at the step 5, the additional 3 carbon fragments of dihydroxyacetone phosphate was converted to glyceraldehyde 3-phosphate. So to kick off the payoff phase of the glycolytic pathway, the glyceraldehyde 3-phosphate is the first substrate, and in step 6, the glyceraldehyde 3-phosphate is converted to 1,3-biphosphoglycerate. 1,3-biphosphoglycerate. So you notice that this aldehyde group, the aldehyde group here this aldehyde group has been converted to a carboxyl group, here with a phosphate group attached. So what you have is the phosphate group attached by the introduction of the phosphate at this aldehyde group, which gives you the from glyceraldehyde 3-phosphate to 1,3-biphosphoglycerate. In step 7, the 1,3-biphosphoglycerate here is converted to 3-phosphoglycerate. So we basically get rid of the phosphate group. We basically got rid of this phosphate group here, leaving the carboxyl group. So what you have is 3-phosphoglycerate. The phosphate group here has been removed, given off, and what you have here left is 3-phosphoglycerate. In step 8, all that happens in step 8 is the changing of 3-phosphoglycerate to 2-phosphoglycerate. So basically what happens here is that there's a switch of the phosphate group. And the OH group. So you noticed in this 3-phosphoglycerate between steps substrate 7 to step 8, through step 8, at carbon 2 you have an OH group attached here. So what has basically happened in with this at 2-phosphoglycerate is that the OH group attached in 3-phosphoglycerate at carbon 2 is switched with the phosphate group attached at carbon 1. So this OH group moves here, while the phosphate group moves to the OH group. So what you have is that switch from 3-phosphoglycerate to 2-phosphoglycerate. It's just the shifting of the phosphate group, the switching of the phosphate group from carbon 3 to attached to carbon 3 to carbon 2. Okay, in step 9, the 2-phosphoglycerate, in step 9, let me zoom out a little. In step 9, the 2-phosphoglycerate is converted to phosphoenol pyruvate, the PEP. But there is a double bond between the carbon 1 and carbon 2. There's a double bond. I'll quickly show you this double bond here. There's a double bond here between the carbon 1 and carbon 2, while the rest of the structure remains the same. So there's an introduction of the double bond at this point. And of course, for this reaction, water is given off. So a kind of a condensation reaction that forms a double bond here. Water is given off from the H2O here, and you have a bond forming at that point. So that's the formation of phosphoenol pyruvate. Moving right along is the 10th step, which is the final step, and that is the conversion of the phosphoenol pyruvate to pyruvate. And this concludes the structures of the molecules involved in glycolysis. So phosphoenol pyruvate is converted here to pyruvate, and that concludes the structures of the molecules involved in glycolysis, which is from one molecule of glucose, as you can see at the preparatory phase over here, one molecule of glucose right through the preparatory phase, a 5-step, to the payoff phase, which is another 5 steps through step 6 to step 10, forming 2 molecules of pyruvate. Now, this whole process from step 6 to step 5 is actually replicated. So how? You see that in step 4 here, fructose 1,6 biphosphate broken down, splitting into 3 carbon sets, one for glyceraldehyde directly produced and the other dihydroxyacetone, which is also subsequently converted to glyceraldehyde 3-phosphate. Now these two molecules of glyceraldehyde 3-phosphate will undergo this exact same reaction at the pair phase from step 6 to step 10. So all we have seen is the specific molecules and reactive steps of one of the molecule of glyceraldehyde 3-phosphate to produce one molecule of pyruvate. The other glyceraldehyde 3-phosphate produced will also undergo this exact same step, producing two molecules of pyruvate. So we'll begin to look at in the next class the overall reaction of the glycolytic pathway. The overall reaction looking at the energy charge, number of ATPs produced, and the whole energy process involved in this fantastic pathway.